So, got a little PowerPoint presentation for you here. For those of you who don't know Tormach, we are a company that was founded 15 years ago with a mission to help people make things. Mostly we've done that by creating CNC machines. We have 5 milling machines, 2 lathes, 2 routers, and a plasma table. But predominantly our goal is to help people make stuff. We've done that by taking really big, powerful, super accurate, expensive industrial equipment that's hard to use. It typically requires a two-year degree or greater in order to use that stuff. And we've made it smaller and a little less powerful and much more affordable and easier to use and accessible. And we're continuing to do that now with industrial automation, which is why you guys are here today. We're headquartered in Madison, Wisconsin. This is a photo of our old office building, although we're in the process of moving to a new building with a little bit less office space and a lot more light industrial space, because we've always had a number of remote employees, but we went remote first during the pandemic. So taking advantage of a need for less office space to find something with a bit more room for the machines. And we're 100% employee owned, which I like tossing in there because I think it's pretty cool to work for a company where the employees are the owners. So enough about Tormach. We'll hit the robot. I don't know if you've all seen this. This is all information that's up on the web. The thing I want to highlight on this slide is that the ZA6 is essentially like any other industrial robot of its size. It's aluminum castings, no plastic on it. They're harmonic drives on all the joints, servo motors with absolute encoders. So some of you know that our products, especially aimed more in the hobbyist or enthusiast market, like the PCNC 440 or the XS Tech router, those products have stepper motors, sometimes industrial capabilities. You can get them to do industrial things, but those do not have a true industrial control. This robot, from a hardware perspective, is very similar to anything you'd see coming from KUKA or Fanuc or Yaskawa or any of the big robot-only folks. 12 ports of digital I/O. 2 of the inputs are reserved for safety functions, so it's really 10 ins and 12 outs, but that should be plenty for anything you might want to do, especially because you can use Python to interface with the outside world via a network connection on your control computer. It's almost 1 meter of reach, and it is controlled by PathPilot, which we'll get to in just a moment. I'm assuming some people want to see a quick tour of the user interface. So if you're familiar with our CNC machines, this is very similar to PathPilot on our milling machines or our lathes or our plasma or our routers. You have a number of controls down at kind of the bottom third of the screen. The stuff over here under the big cycle start button, these are all program controls, so it allows you to vary the feed rate or the maximum velocity the robot can achieve. We have, stop, you can reset things. Feed hold, single block is a CNC-ism. It'll just execute 1 line of code at a time. And optional pause is another CNC-ism, which is you can insert areas of code in the program where if you have this toggled, it'll pause when it hits that line of code. If you have this untoggled, it won't. Here in the middle are all the position readouts. We've got currently got the a different offset applied here, but you can see in world coordinates, these are in millimeters. They could be displayed in inches. It's a setting on the setting screen. And you can type into these things. So we could we could change, for instance, some of these values just by typing in. I could change this from Z to 10, for instance, and that would change where the machine was going to go to when I run this program. And then we have joint values. And then lastly, these controls here on the right-hand side affect how the machine jogs. File tabs, not much. Oh, I could look up at the top. We've got a display of the robot itself, along with the current user frame that's active. So this here shows the 000 point for offset 1. If I go over to offset 2, it moves to right there. And then see if we're above the vice, kind of somewhere down there. I think that one just has a Z offset applied, doesn't have any X, Y, or ABC offsets, and tool offsets. And over here, we see the active program. And we'll hit this again in a moment, but this is Python. It's just regular Python. It's not a proprietary language like some other industrial robots. FANUC uses Carol. You could load any Python program in here and click cycle start, and it would go off and run it, which makes it incredibly flexible and powerful. Before we started this talk, one of the folks in here was talking about creating a custom user interface for something, and you can do it incredibly easy. I have some examples even of how to create custom UIs right here in the Python program that the robot runs. It's pretty neat. File tab, not much to see here, just a list of the files that are on the computer's hard drive and some utilities for moving stuff over from USB. Anyone that knows PathPilot for our CNC machines knows we have PathPilot Hub, which is it's an online file storage system. You can use it to transfer files back and forth. Offset screen, I don't want to go into in this call unless people have specific questions. User frames, tool frames in robotics are analogous to offsets, tool offsets and work offsets in CNC. It's somewhat complex, but the one thing I do want to highlight in here is that if you have a Tormach CNC machine running PathPilot at your facility and you have one of these ZA6 robots, you can actually connect via network connection those two controllers, and they'll talk to each other, and you can have the robot issue, cycle start or MDI commands or file load, just arbitrary commands. The robot kind of becomes the hypervisor of the CNC machine. And if you create a set of machine offsets, you can actually bring the CNC machine's solid model into the robot's collision scene, and the robot will become aware of that Tormach CNC machine so that it won't allow you to collide with it. Settings tab, we can skip. Conversational, this is one thing I really did want to show. We'll go ahead and just create a new program here, and I'll show you a few of the things. I mentioned the robot interprets Python programs here. And so if you don't know how to program Python, you might be thinking, well, how the heck am I going to create a robot program? But we've added a lot of utilities that make it very easy. So let's run through that. I'll go ahead and jog the robot around. There are a number of ways we can jog the robot. I can just grab this marker here and I can drag it, and then I can hold the hold to move to marker button down, and it'll move. And it'll give me an error warning here. No offset active. Okay, why don't I just change that? Sorry about that. So I can do that. Maybe I start a little simpler. I can very easily, in increments of 10 degrees, 100 degrees, 1 degree, I can jog individual joints. So if I click the J1 button, you can see I'm just moving the first joint by 10 degrees at a turn. Likewise, J2, 10 degrees. Right now I'm doing this in kind of a step mode, but I could do it continuously. So I could just, as long as I hold the button, it'll jog. I showed you that you can jog using this ball by dragging it around, and then wherever the ball goes to, you can click hold to move to marker. We also have keyboard shortcuts here. So right arrow, left arrow, you won't be able to see me doing this because it's just me holding down a keyboard key. But let's say I go page up, it's going to jog up in Z by 10 millimeters a time here. 100 millimeters might be a little easier to see. And then these buttons over here do very similar stuff. So when I'm holding the page up key up or down, pretty easy to move stuff around. We have a bit more that you can do here as well. I can align the tool's current position. That wasn't very dramatic. Let me just pick a different one here. If I align something like that, we'll see that it moves the tool around to kind of a right-hand orientation, right? So this is fairly useful if you need to align the flange of the tool normal to gravity, for instance. I'll go ahead and move it back. And then lastly, I can just type values directly in here. If I want this at, say, 450 millimeters above in C, I can just go ahead and do that. Waypoints, fairly simple. You can just go ahead and drop them from any position. There are different types of waypoints. Pose types are kind of Cartesian poses, like XYZ positions. Joint waypoints are just, we're storing the joint angle values. So I'll go ahead and store this as a joint waypoint type. You can see over here that we've just stored it. It says type joints, and then you see here 15 degrees off of J1's home position. That's how we've stored this joint position. Joint positions aren't affected by changes to the user frame. If we were to record this waypoint as a pose type waypoint, I'll give you an example of this, and we go over to the conversational screen, you'll see here this second one's pose type, and we have an X value, a Y value, a Z value. That's X, Y, Z in Cartesian space. And then you have an A, a B, and a C value. You can think of that as yaw, tilt, and roll. Technically, A is rotation around the X-axis, B is rotation around the Y-axis, and C is rotation around the Z-axis. But this pose type waypoint would be affected if I changed the user frame of the program. So if I created a work offset local to a specific point, the robot would move to a different position in a program. So adding these things to a program, pretty easy. You just toss them in there and we can save it, and then test for webinar. And we can go ahead and, uh-oh. Did I not create the extra waypoint at the correct spot? What happens during a demo? Let me make, I think I failed to actually move it to this new place. Give me a moment here. New point, oh, here. You know what we do? Update waypoint from current position. Sure. Save, and that's how easy it is to create a program there. Ha ha! You gotta love demos that don't work. Let's try that one last time, shall we?
I think you've got 2 move J's to the same waypoint.
Oh, do I? Oh, thank you so much. How about that? This is great. I don't know who added that comment in, but I really appreciate it.
You got it.
So that's how easy it is to create just a simple program that moves from one spot to another. We have a lot of other things you could add in here, so you can very easily set digital outputs. These digital outputs, by the way, are nameable. So if you don't select a name to it, it's just going to be output 6. But if we came over here and I said we're going to call this webinar output, we could go ahead and change this output to low or high. It's 24-volt outputs, easy enough to connect to a relay if you need a dry contact output. We can also, and since I don't have anything connected to it right now, this wouldn't actually do much, but I'll go ahead and toss it in there. We have wait commands. We could wait for a number of seconds. We could wait for the digital input to change state, right? So I have a probe hooked up right now. I don't know if that would be a good one to actually wait on. We could just put in a pause or an optional pause. You can allow jogging. We have notifications, so we could have a message in here that says, hello, everyone. You get the idea here. This tab allows you to put in arbitrary commands to a connected PathPilot machine. I don't have a mill in my garage right now, so I can't show you that utility, but you get the idea. If you had multiple PathPilot machines connected, you could select them. We have some utilities that allow you to write subprograms, put in if-else statements, assignment to variables or comments in the code. I won't bother showing that, but I did want to just give you this idea that it's relatively easy to create simple programs just by the conversational programming language. So you've seen conversational, you've seen jogging. What's left that I wanted to talk about is this stuff here, this Python. So I'm going to go ahead and bounce over to a, this is just a Python program editor here, and we'll take a look at that file that we were just working on. What did I call it? Webinar, test for webinar. So this is regular old Python with some of our commands that have, that will be interpreted and cause the robot to move. But the nice thing about a robot that interprets Python is that you can do almost anything with it. And so I've done this example a few times. This is really just a handful of lines of code that uses Google's text-to-speech library. And we can have the robot talking to us. So I could say, who was I talking to earlier? Bo. I don't know if Google text-to-speech is going to get your name pronounced correctly, Bo, but we'll give it a try. Go ahead and load this up, and we'll see what happens.
Hello, Bo.
So, you know, a robot that talks to you is fun and it's kind of cool. I've actually found it to be useful a couple of times when I've been training the robot to execute a series of kind of precise but small moves, and I wasn't sure where it was in the program. I just inserted a number of speech commands that say, hey, I'm on step 4, which is helpful. But that gives you an idea what you can do with Python. Another example here, I wrote very quickly using Twilio's library, a program that'll send text messages, right? So this takes a look at the Twilio application, and it'll take a photo, and it'll go ahead and send that photo to my phone. So if we run this, let me dial the feed rate down a little bit here. This will go ahead and it sends something to my phone with, I don't know if this will show up here, but at some point in time, my phone will get a text message. Oh, maybe not. No. Interesting. Oh, I don't have a webcam plugged into this thing. If that's it. Or maybe it's because I'm screen sharing on Zoom. In any event, the point here was to illustrate how easy it is to do a lot of stuff that would be really challenging to do if you're programming in Carol with a FANUC robot, you can do with Python. So earlier, right before this meeting, another example, I was importing the CSV library here in Python, and I was probing a number of points on this vice, and I was going to write them out to a CSV file. So that's kind of what I had for the tour. And I'm going to bop back to the PowerPoint presentation here. I'm going to talk a little bit about what I see as the advantages of this robot, and then I'm going to hit some of the limitations, and then we'll get into some questions. So I think one of the big advantages here is that it's just incredibly easy to use. You saw me create a very simple program. I appreciate the debugging there from one of the participants. For the most part, this is incredibly easy to use. My kids play with it, and they're 11 and 14 years old, and they had no trouble at all getting over that initial hump of how do I get this thing moving around? How do I get it doing something useful? You don't have to know Python to program the robot because, well, you know, if you're moving from point A to point B, if you're doing welding, if you're moving stuff around, if you have a simple application where you just need to move something around in space, no need for Python. You can do a lot of very standard tasks right from our interface. And like the rest of PathPilot stuff, soon we'll have our online PathPilot interface will be up, and you can simulate any of this online. Not there now, but it'll be coming soon. The real cost advantage here, I think, is in ownership of the technology. And I want to illustrate that by giving you a quick story about a friend of mine here in Madison that has a company that does a lot of welding. And it's pretty simple welding. It's all fairly small weld passes on 1/4-inch steel. And they're looking to automate it. And he asked me what his options were. He knows that I'm in automation, and he asked me for some advice. And I said, you know, if you don't have anybody with any technical aptitude on your staff, and you need somebody to create something where you press a button and it makes the weld, then there are plenty of people out there. There's great companies in Madison that do industrial automation, and for $100,000 or $150,000, they will deliver you something that makes your parts when you press that button. But the moment you introduce a new part or you need to change a part, you're going back to those guys to get the program changed, right? Because you won't own that technology. If you go a different route, which is if you say, you know what, this is easy enough, I think I can figure it out, perhaps with some help from an online community or some help from Tormach tech support, you end up owning the technology. You really own the tool, and you get to understand the full capabilities of the tool. You may apply it in things that in ways that you didn't foresee originally. So I don't know if I'm conveying that idea properly, but I think understanding the technology behind it really helps you succeed in whatever your application is, whether it's, you know, production of welded parts or teaching or film and video. So I touched on this a bit, even though my little picture message example didn't work. I'm convinced that having Python as the robot's programming language is a massive advantage. Python's not that hard. I don't know how many people on this call are familiar with Python. I scrolled through some of the audience before we got here on the HubSpot interest form that you all filled out at some point in time. And I know some of you are technically savvy. We have customers on our CNC machine side that learn G code. G code is a hard language to program in. It's archaic. And there are probably 100 times more Python resources out there than there are G code programming resources. Python's not a hard language to learn, and once you learn it, it's incredibly powerful. The ability to integrate things with the outside world through Python, through that robot program, being a native Python program, is incredibly powerful. And it goes beyond having the robot talk to you or sending you a text message. You know, you could have the robot hitting a web server with an HTTP request via the Python requests library. You could bring in computer vision with OpenCV. I'm working on a demo now that I'm going to post up on our shared programs page using Google's Teachable Machine, where I'm able to train a visual recognition model. And for instance, if I held one type of welded part under a camera, the robot would know, oh, I'm going to use this program to weld that part. If I hold a different type of welded part under the camera, so it recognizes the thing it's supposed to weld on and it acts accordingly. That's something that'd be very hard to do with a traditional industrial robot that did not run Python as its programming language. If you're a teacher, and if you happen to be a teacher who teaches Python, I could tell you, I've tried to teach Python to my kids and they get bored after, you know, about 30 minutes of playing around with the terminal console output. If you have something moving as a result of a student's code that's written, kids get really, really excited about it. And so I think, especially when we have a smaller, maybe more middle and high school friendly product out that's running the same interface, I think it's going to be a slam dunk for education. And then if you are a robot integrator, if you're somebody that is often asked to come up with kind of a proof of concept for a client, there's no better way to rapid prototype an application than a robot that interprets Python. And then lastly, I've alluded to this a couple of times, but I should show it to you. We have a shared code example library here. So I just want to show you, I'm here online. This is our user documentation. We have a user forum around this. So here's an example. I was talking about the welding, my friend with the welding application. We had it laying down beads in, I don't know, 45 minutes or so. And most of that was connecting a relay to the welder's trigger. And within about an hour and a half, we had it actually welding the guy's parts and doing a nice job of it. This is a video of it welding that little part in there. And so this kind of comes back to that idea of owning the technology. We didn't envision this as a welding robot, but if you know enough about how to use it, it wasn't that hard to set it up as a welding robot. And then we put the examples here up on our user forums for other people to learn about and to see. And then we take the code that's used in some of these examples and we put them up on GitHub so people can start reading the code that we've written and learning from it. And so you can see here examples of the actual code that was behind that text message thing. It's 26 lines of code there. Pretty simple stuff. User community, just hit that. This is a place where we expect not only Tormach developers to contribute and help people out, but also other people to learn from each other as they create interesting applications. One of the things that's already up here is one of our beta users went to a trade show and put a camera on the end of the robot and downloaded Twitter's API and had the robot taking photos of people at the event and then tweeting out those photos. And the robot was doing all of it. I thought that was pretty neat. An advantage I haven't talked about much is ROS. I don't know if you came to this webinar through Shane's video of the robot chainsaw or through one of the other videos we've done. I did a ROS presentation for the ROS Industrial Consortium a while ago. ROS stands for Robot Operating System, and it's a massive open source software development project aimed at controlling robots. It allows people to do some pretty amazing stuff. And in particular, it's a hot topic in robotics research. And if there are any academics in this call doing robotics research, I'm sure you know of ROS. The nice thing about the ZA6 is it just works natively with ROS out of the box. ROS is doing the underlying motion control for this robot. And we give you access to everything in real time. There's no hidden stuff. I probably got a good example of that over here. We'll just hop on back to the user interface. And I'll open up that first program that we were doing, subprogram example. I'm gonna go ahead and start this. Wait a minute. This is an example here of some of this stuff here. So if I want to take a look at, for instance, if I wanted to take a look at the torque, this here is the torque on joint 3. And this is the torque in real time. Oh no, sorry. Red is joint 3's actual velocity, and blue is joint 3's actual torque here. And to give you an idea what that actually looks like, if I stop the robot here, you can see no velocity. There's a little torque on it because it's sitting there holding the rest of the arm up. But if I go here and I kind of press on the robot, you can see that torque value move around. I assume you saw that torque value move around in real time. So that's another example here of, for those that are interested in ROS, we make a lot of stuff available under the hood that you wouldn't get out of other robots. And then of course we have a lot of this code is open source. It's up on GitHub. If you're an educator, I think that this robot is fantastic for teaching industrial robot concepts. I mean, it does everything that other industrial robots do, and the underlying principles are identical. So you could teach, anything related to kinematics of a 6 degree of freedom robot arm, talk about joint space or Cartesian space, Euler angles, robot frames, anything. And at the end of the day, you have a robot your students can actually get their hands on and use and feel comfortable with because the interface is incredibly easy. And if you're into robotics research, it does double duty because of the ROS angle. So I've been blathering on about the advantages for a bit. I want to talk about some of the limitations. I do not want to oversell this to people. The big limitation here, it's not in the hardware, it's the software. It's relatively new, and we're still working out a few bugs, as you probably noticed in my demo. I think I should have gotten an error or a warning message when I tried to do 2 linear moves or joint moves to the same waypoint, but I didn't. That'll be going up on our bug tracker, and we'll get that one fixed right away. I want to point out that the big industrial roboticists like Fanuc or ABB or Yaskawa, they've been doing robot motion control for 35 years. ROS is incredibly powerful. I've driven in a self-driving diesel Peterbilt semi-truck that was controlled by ROS, right? It's a very flexible robotic control framework. It's only been around for 10 or 15 years, and it's mostly aimed at dynamic planning, meaning what happens if a user walks into the collision model and we're using a LiDAR sensor and we've got to replan That's where ROS really shines. We're adapting it to be robust for an industrial robot in industrial robot applications, but it's not where FANUC and ABB are. That's something you should be aware of. Some specific examples of those limitations. I don't know if I could cook one up here, but if you're moving in a Cartesian trajectory, so XYZ point to XYZ point, you know, there are almost infinite paths that the robot could take between 2 points. But you'd expect if once it makes the first choice, it's going to keep taking that same path each and every single time. If you're moving a large distance, because of the dynamic path planning strengths of ROS, it does not always choose the same path, which can be kind of surprising or unnerving to people. That's something we're working on knocking down. There are workarounds to it. You can just do joint type waypoints prior to executing smaller Cartesian waypoints. But that's one of the limitations. We don't pre-process robot programs. So if you're going to violate some motion limit, you're not going to find out until you're halfway through your program. Not a problem if you're teaching the robot via conversational screens, but if you're using SpruteCam or Autodesk Fusion 360 to program robot moves, you know, you'd like to know whether it's going to succeed before you press cycle start, not 20 minutes into the program. We don't have a process move. This is a big limitation. It's one we're working on, but we haven't solved yet. That welding application works because they are very short welds, and I can approximate a tool control point moving at a set linear velocity. But if you're depositing adhesive around something that's 2 meters long, I can't guarantee that you're always going to be going at 10 meters a minute, 10 inches a minute, or similar. That's something that we are working on. In particular, if you have a welding application, you should be, you know, this is a red flag unless your welding application has pretty small discrete moves, or you're willing to do a lot of duct tape and bubble gum. It's something we're working on, not there yet. And then I have a couple of slides here of who I thought might be interested, but as I was looking over the areas of interest that you all filled out on our form on our website, I see it's very diverse crowd here. So immediately, until we get some of those fixes I mentioned on the last slide in place, immediately I think this robot it's appropriate for people teaching. It's appropriate for industrial automation enthusiasts. That's a mouthful, and some of you might be wondering who on earth is an industrial automation enthusiast, but we have a lot of customers that know that industrial automation robotics is coming, and it's a thing they should be paying attention to. They know they need to learn about machine tending, or they need to learn about robotic welding. I want to emphasize this is not a super polished professional solution for those applications. That's what we're working towards, but we're not there quite yet. So if you're an automation enthusiast and you want to use this product to learn about industrial automation, and you're willing to work around a couple rough edges as we continue to improve the software, which, by the way, updates come for free over the internet. It's like a PathPilot CNC control where every month or two you get a notification that you could download the latest and greatest if you want to. So I think industrial automation enthusiasts would find it appropriate. If you're doing ROS research and development, it's absolutely appropriate. And I think film and video folks can find ways to make this product very useful. In the near future, I think it will be a very appropriate tool for businesses that have automation needs who are willing to learn a technology and have some ownership of it. If you want a button to press, you know, and your operator doesn't need to know anything about a robot, or your programmer isn't going to need to know anything, then you're better off going to an integrator to have them cook that button up for you. But as we mentioned earlier, I think it's more powerful to own this technology itself. We're working on machine tending. This is one of the reasons we did it. It dovetails nicely in with our CNC products. I have to tell you, our CNC products aren't terribly suitable for machine tending right now. We don't have chip conveyors. We don't have automated door openers. There's a lot of stuff that we need to do on the CNC product side before a Tormach machine is the right fit, but perhaps you could bear with us as we're figuring those things out, or put the robot on a different machine. And welding, lastly, although with that big caveat before of the process move. I'd just be happy to take questions or get some feedback. Any questions on any of the stuff that you saw? Davey raising his hand. You can just unmute yourself and chime in. You don't have to raise your hand.
Well, I didn't want to jump on top of somebody else. So you mentioned that we can hook a Tormach mill into this and send MDI line commands and cycle start. If I had a FANUC, for example, mill, can I do something similar with that to where I can communicate with it?
You can certainly communicate with it, but it would be a dry context type of communication. So typically, if you have, and this is true of almost all machine work cells, up until a couple of folks in the very recent last couple of years, what you're looking at is a set of digital outputs and inputs. And essentially the robot is going to say, I'm ready for you, or the mill is going to say, I'm ready for you. And the robot would toggle an output saying, I'm doing my thing. I'll let you know when I'm done. And so you typically would do that with just a handshake. So if you have a FANUC milling machine and you wanted to tend it with this robot, you'd be doing just an I/O connection to one of the FANUC's inputs, and you'd be reading those commands in via M code, M65, M64, or something like that.
But if there's USB ports available, I could do a USB to Modbus type of situation with some Python to send a command somewhere.
That would be highly dependent on the FANUC control.
Oh, sure, absolutely. I'm just shooting for the moon here.
Yeah. I don't know of any other controller that would allow you to, via network connection, send commands to the control. Many industrial machine tool controls do talk over something called MT Connect, which is a protocol for communicating status messages. But the last time I looked at it, it did not have a provision for saying, okay, now it's time to start the cycle. Not to get too far into the weeds, but what I would do if I were in that situation, any I/O that was required to automate the mill, so the pneumatic closer for the door, or the blow-off nozzle for the chip evacuation to get the chips blown off the part before you pick it up off the vise, or the proc sensor to tell that the door is fully closed or fully open, I'd run that back to the robot. And then I would have the robot in control, and I'd have the mill running in a loop. You'd have just a big subroutine or a program with an M99 loop command at the bottom. And at the very top, you'd have an M65 check digital input, and you'd basically sit there waiting for the digital input to change state. And as soon as it changed state, that's the robot toggling one of its outputs saying, I'm done. You can go ahead and machine this part. And then at the end, it would pop right back up, and the robot would handle everything else, the door, the nozzles, all the rest of that stuff. That's how I would set it up if I were doing that.
I had a question on a couple scenarios. What does the robot do if it loses power?
I just conked the power to it. What happens on the user interface is that we get kind of a flashing reset button here saying the machine's gone into reset, but the robot itself, there are normally activated brakes on all of the axes. And so if it loses power, the brakes just go and they grab it, and it's very hard to move it with the brakes applied. So if I fire it back up, I can tell you it's also very similar to the behavior of the robot if, oops, gotta actually power the e-stop circuit on too. It's similar to the robot's behavior if I trip the safety circuit. So what I have here is a light curtain. I don't know if you can see, this is a light curtain here.
Yeah.
And if I break the light curtain, the robot goes into a safe state. You saw the Maxwell slider go to 10% and the reset button start flashing. But if this connection is broken, like if I put my hand in there, you can hear the brakes activate. I don't know if did you hear that?
Yeah.
Almost identical to if it loses power. It just stops itself. If it were moving when I did that, it would just stop itself.
All right. Cool. Thank you.
Hey, Daniel, thank you. I just wanted to know, I was curious how many of these machines were out in the wild and what's the availability right now or
Sure.
in the near future?
So we did, not counting the prototypes that we've got at various developers' garages like mine, we've got 10 what we'll call pre-production units. They're going to be pretty much identical to the production units, except for a paint color change on the cabinet, and we changed the I/O connector style to M12 from GX16. Otherwise, identical to the one that you see here. We've got 10 of those out in the wild. A couple of them are at Tormach, and the rest are at beta testers sites. So we have a number of different beta testers. One is definitely that industrial automation enthusiast. He's got a machine shop. He just wants to educate himself about machine tending. And he happens also to have a previous life as a programmer. And so this is just right up his alley. Another one went to Southwest Research Institute for a while. They're the head of the Ross Industrial Consortium, and then moved over to another company that does Ross-related software development. And then we've got one at Oak Ridge National Labs, one at Rensselaer Polytechnic, which is the home of the Arm Institute, a couple with just kind of robot enthusiasts that were Tormach friends and family that had backgrounds in industrial robotics. Yeah, so I guess your answer is 10. And then we'll have another 20 available for sale. They should be available for sale in November.
I had a quick question.
Mm-hmm.
Yes. Were any of your beta testers any like cinematographers or anybody that actually used it for video?
No, and I wish they had been. So we were approached after I had selected the beta program. We were approached by a video studio that just begged me for one. I hadn't even realized that film and video was a thing in robotics until I had this conversation with these guys. And it became clear to me after talking to them that there was really a market for that type of thing and a need for it. And that people in the film and video space oftentimes are spending more money on like a 1 or 2 axis actuator to move a camera around in a precise way. So we haven't done a ton of development to enable that space. Like what I would eventually like to do is make some alteration to our trajectory planner that would prioritize. Trajectory planning is really interesting in robotics, right? Because you can go from point A to point B just a million different ways. And so what do you want to optimize? Do you want to optimize the shortest path? Do you want to optimize the fastest path, which is not always the shortest path? If you have collision objects in the scene, there's optimization around collision. But one thing that you could optimize is, imagine I have a camera and I want to move it from here to over here, but I always want to have it focused on this object, right? So I can actually optimize a trajectory planner to have the robot pointing in the same direction all the time. Or, this is going to take a bit longer, but using a technique called visual servoing and some object identification, you could have a camera whose input was going back through the computer, where you identify the object that you want to keep in the frame, and then the robot moves, always keeping that image in frame. We did a poor man's version of that using this little guy. It's a DJI Pocket Express with the camera, and that's something one of our beta testers did. He's got a blog, and he's into film and video. So I wouldn't call him a film and video person. He's not he's professionally, he's a roboticist. But the results were really cool watching the robot take film of him as it moved around. It's definitely something I'd like to work on from a software standpoint in the future, although our immediate focus was getting this ready for the other audiences that I talked about. I still think there's a lot of utility there. And I think there's a lot of ways you can make it useful. In particular, one thing I didn't show, I talked about executing a toolpath that was created by SpruteCam or Fusion. There's a product called Maya, which is an animation package from Autodesk. And we do have a utility that'll take an animation in Maya and have it played back by the robot. So I've got
like
the
mimic
robot.
for Maya.
Yeah, exactly. Yeah. So we have a rig for the ZA6 and Mimic. And if you know Mimic well enough, you could create a camera in Mimic, and you could do your robot animations in Mimic, and then you put that actual camera on the robot, and you can replay those moves.
Cool.
So
I used to work for a cinema robotics company, and
oh, cool.
So yeah, I'm very well versed with them. So just curious. I mean, this is your price point by far is the best when it comes to like the cinema world. So I think a lot of people are going to be interested.
Well, good to hear. I appreciate that feedback. And I want to reinforce this idea that we're kind of going into this new realm, and we really do want to work together, especially with the first people that buy this thing. We're going to be doing a lot of hand holding, and really the first people that adopt this product are going to be able to shape some of the direction that we take it in. So yeah, the Mimic stuff has been really neat.
Just one other question. When are you going to be taking deposits at all for those first 20?
That's a good question. Lori, are we going to be taking deposits for the first 20?
We definitely can do that. That's something when we turn it on for sale, you can order it right then and there, but we'll come up with a plan for early deposits.
To be completely open with you on the plan here, I had those 2 slides of audiences, right? And I said, these folks, this is immediately, I think it's a good fit. And then these folks, soon, I think it'll be a good fit. I'd much rather sell this product to people. I don't want to get that call that says, you know what, I had 900 pieces to weld and I took delivery of this on Monday and it's Wednesday already and it's not working. I want my money back. It's not the person I want to sell this to, right? There are going to be some hiccups, and I'm looking for people who want to help participate. And in return for that, we're going to give them a lot of attention on the development side. And so I think from the deposit taking standpoint, we might do a little bit of a conversation with some of the folks that want to buy the first 20 of them and make sure that the fit is correct, because I want to make sure people understand what they're getting into with this. It's not a way to save $80,000 from buying a FANUC, right? If you're welding a bunch of doors for GM, this isn't your robot this year. It might be your robot in a couple of years, but right now, if you're General Motors and you're making doors on the assembly line, that's a FANUC robot that you want.
I have some curiosities with the code. I remember you showing the torque curves and everything. Within the Python script, can you gain that data of things like the motor rotation speed and the torque and everything in real time?
You can. It's kind of interesting how you access it, though. Let me see if I got an example there. No, I want to share from the other computer. Sorry. Here's an example in Python of reading a value from a HAL pin. So HAL stands for hardware abstraction layer, and that's kind of the lowest level where we have things like torque or velocity or motor rotations, current, any of that stuff. So very simple piece of, and really this establishes the pin, and then this gets the value from the pin, right? And then notify just says, hey, look, this is the torque on that pin. If I go back to the robot, the interesting thing is that code that I just showed you, it gets you that pin at a point in time. It doesn't get you that pin. It doesn't get you the HAL pin value in a way that I think you might want to use it. And I'm guessing you're thinking, what if I just moved this joint until the torque on that joint exceeded some amount? That we're working on. We don't really have a great interrupt function yet. Like, hey, I just want you to, watch this thing over here while this other stuff happens. The only interrupt we have is on the probe input. Move until the probe trips. But we are working on a way to attach watching a value change and then interrupting the program based on that value change. And that, I think we'll probably have that ready when we release the product.
One of the first things that I thought of when you show those torque curves is if you just had the robot kind of in a stationary state and within Python loop and check what the torques are on the joints, you could essentially convert it to a collaborative robot. It seems sensitive enough so that you can detect when you start pushing it, and then I don't know.
Yeah, so there are a couple of caveats there. One is one of the big differences between an industrial robot and a collaborative robot is there's a lot of safety involved in the collaborative robot that we don't have implemented. A collaborative robot requires a completely separate processor that is always checking the commanded and actual positions of the robot to make sure that the processor hasn't gone out to lunch. And then you've got to limit joint speeds artificially to a value that is deemed to be collaborative. We considered doing a collaborative robot early on. I'm not going to say we will never do a collaborative robot, but I can tell you that the majority of people that we interviewed when we were starting to walk down the robotics road said, the folks that did buy a collaborative robot said, boy, 2-3 months after we installed the thing, I called the integrator to come back to the shop and put fence around it so we could run it as an industrial robot faster and not in collaborative mode. Collaborative robots are some of the fastest growing, part of the robot industry, but the feedback that I've heard from people that own them wasn't super positive, which is why we didn't go down that route. The other thing is this has encoders on the motors themselves, but a collaborative robot typically will have a second set of encoders just on the joints in order to enable gravity compensation. So long-winded answer is we could probably get close to a collaborative robot by looking at those values, but it wouldn't be a true collaborative robot implementation. And so we haven't done
That's definitely more what I would aim for, because the limitations with safety and everything can be annoying, but being able to program a robot via a collaborative method by pushing it around, I found is the easiest way to do things.
Yeah. You could use those values, for instance, to weigh the payload. That'd be a very easy application of grabbing the value of the torque out of one of the joints. It'd be pretty easy to infer the weight of the payload from that value.
The other quick question I had is with the I/O pins. I know you were saying kind of they're only set to on and off. Would it be possible to have the I/O pins like send commands out? It's only a single pin, so I guess in I2C or other communication methods.
Oh, I think if you wanted to do that, there's a bazillion different things you could do just from the fact that you've got a computer in Python at your fingertips. So, you could do a serial communication, you could do HTTP communication, all sorts of stuff. Kind of depends on what's on the other end that you're trying to talk to.
For end of arm tooling, is it sort of you bring your own, or are you guys working on some of that?
We have a pretty limited selection right now that we're going to sell with the robot. And I wish I had an example here, but I don't. We've got a couple of parallel jaw 2-finger pneumatic grippers, low cost. They're kind of ubiquitous in the robotics world. And we've got, this is an example of one of the solenoid. This guy just mounts right up to the robot cabinet itself, plugs right in, and it takes 4mm pneumatic tubing, and that would plug right into the grippers. And so we do sell that. So we've got a 2-finger pneumatic gripper. We've got the probe. We've got a product by a really neat company called VersaBuilt in Idaho that they do exchangeable soft jaw systems for pneumatic vise. So we've got their gripper that works with this robot. We've got some stuff that we're gonna work to bring online. So this is a sample that I've got that we'll probably add to the catalog, and it's it actually takes air pressure to create a venturi to do suction, and it'll pick stuff up with remarkable force. So if it's flat enough to get a hold of, it'll grab it quite well. One of our beta testers is using this product and really likes it. After that, hoping to see what people start using and be able to help them access it better. It's a huge range of end of arm tooling that's available, and unfortunately the market for that stuff doesn't make it really easy for individuals to access it. A lot of that stuff is purchased through resellers. In many ways, the industrial automation industry reminds me a lot of the CNC industry 15 years ago. And 15 years ago, if you wanted to use a CNC machine, couldn't find one that was going to fit in a non-industrial space because they're all 3-phase 480 volt machines. In order to operate one, the user interface was really challenging. You had to go to at least a 2-year technical school to learn how to use it. You were shelling out a lot of money for it. It just was not accessible to a lot of people. And I think industrial automation feels like that to me right now. You know, you go to buy something like this, and odds are the salesperson doesn't want to talk to you about it because you're only buying one. I've talked to a lot of people that have approached FANUC for a single robot and just been set, you know, basically we're told, no, we're not interested. So we're hoping to make it accessible and easier to use, easier to learn, because I think there are a lot of applications out there for something like this. So,
and this is a little tangent to that, but do you guys have a sense of, are sales going to be mostly direct or through an integrator, or how do you envision that working, and what's that relationship like?
My hope is that sales are mostly direct. I really want to try and make this easy enough for people to understand how to use it themselves. In fact, my friend with the welding application, I said, you know, if you want to hire somebody to get this robot making all your welds for you, then I'm not interested in you having this robot. If you want to take your shop foreman and I'll spend a couple hours with them teaching them how to use the robot, then you can borrow it for 6 months and let me know if it works. I think if we can help individuals learn it themselves, they get so much more out of it than if they purchase it through an integrator. That said, there are some tasks that are super challenging that most people are going to have a really hard time doing without the help of an integrator. And I'd be happy to participate in that too, particularly when it relates to ROS. So I've got a company that's been interested in one of these. They have an application that's like, it's a meat processing application for robotics. And it's not something they're going to be successful with, you know, teaching. It's require multiple cameras and range finding, a lot of intelligence. And in that situation, I think it's really appropriate to connect them with an integrator, especially somebody who specializes in ROS. And we do have a couple of folks that are really well versed in ROS programming that we've connected folks to in the past. Because that's the kind of thing that you can do, you know, that's where ROS really shines, is those kind of crazy intelligent applications, dynamic reaction to real world stuff.
Great, thank you.
You bet. Any other questions?
Oh yeah, one more question. So on your website, you put that at some point you'll be working with Maya, but you don't really have a exact kind of timeline for that. Has that changed at all?
Oh, the last time, you know, as stuff changes, sometimes you have to go back and make sure that things are still working. So I don't want to overstate this, but a couple months ago, I was in Maya exporting trajectories and having the robot read them in. So I think the next step is getting somebody using it and finding out what they like and don't like about it. But I can tell you right now, if you export a trajectory from Maya as a CSV file, the robot reads it in without a problem.
Awesome.
I wanted to ask what this machine sort of looks like in 5 years' time, or maybe even 10 years' time. Like, is there at this point a goal, or really this stage of research is about finding that goal?
That's a great question. Thank you for that, Chris. I got a long-winded answer for you, so my apologies. Many years ago, Tormach's CNC machines worked with a control software product called Mach 3. And we didn't like that solution. We really wanted to come up with a control software that was really easy to use, but also really capable and powerful. And so we developed PathPilot, which is based on an open source motion control project called Linux CNC. So the underpinnings of PathPilot, the CNC app, are Linux CNC. And what we did was we put a really great user interface on top of it, and we cleaned up a bunch of bugs. And where we needed to improve the performance, we invested in performance improvements. when we did that with Linux CNC, there was some fear of, oh my God, you're basing a commercial product on an open source software package. Is this a good idea? What if everybody wants the source code? What if your competitors take it from you? You know, when we looked back, 5 years into PathPilot, we realized those fears were not well founded. None of the bad stuff came to pass, and a lot of great stuff that we had not anticipated came to pass. So relationships with software developers, relationships with other people in the community, shared development, sometimes free development, free technology that came along. We had a very positive experience collaborating with that group. We then became aware of Ross, and we were just blown away at what was going on by Ross. And so, as strange as it probably sounds, we didn't see, oh, look, there's a giant hole in the market for a robot arm. We should probably fill it. It was more, boy, there's really something to this software movement that's going on here. And we need to educate ourselves about it and collaborate with these folks. And an industrial arm just felt like a good fit. I mean, we don't make self-driving cars, and we don't do Roomba vacuums, and we don't do automated forklifts. So industrial arm really felt like a good fit for us, especially because we make CNC machines, and machine tending is a really common application for robots. So I'll tell you that my personal goal for this product is that in 5 years, you could walk into a garage, not unlike the one I'm in now, 2-car garage in suburban America. And instead of seeing a minivan and like a couple of kids' bikes in the corner, you'd walk in and you'd see a couple of Tormach CNC machines and a robot working completely autonomously with no human intervention or interaction, 24/7, churning parts out to help bring cottage industry back to the United States. That's what I want to see in 5 years. That's my personal goal for this. That said, I had a feeling when we started working on this product, as people got their hands on it, and I know this because our developers got their hands on it and they started doing wacky things with it. I had this feeling that people were going to come up with uses for this that we could never anticipate. And film and video is a great example. I didn't know that people wanted to put cameras on the end of robots. I mean, I suppose if I were a film and video person, I would know that. But as somebody who spends a lot of time in CNC world and a little bit of time in robotics, I did not anticipate that. I suspect there will be other applications. I didn't know anybody was going to want to cut meat with it. I think that there are going to be a lot of applications that we didn't anticipate. And so in 5 years, I want to stay true to that kind of original mission, because I think it'd be incredibly powerful if for $50,000 or $60,000, somebody could buy a work cell that is programmable without a 2-year degree in industrial automation or machine tool technology, and park it in their garage. And, we sell, I don't know, Chris, if you're familiar with Tormach or if you came in through the robot side, but we sell machine tools to a lot of folks that have this dream of producing a product. They quit their day job, they make a business out of it because they will prototype the stuff and then produce their product on our machine tools. I'd love that not to be I have to quit my job decision. I'd love it to be I'm going to take 3 weeks off from my job. I'm going to set up this work cell in my garage, and then I'm going to go back to doing my job. And if this thing pays for itself, great. And if it doesn't, I'll keep working my day job. Kind of proposition. I think we really could bring a lot of manufacturing back to the United States on that small kind of individual level, or even, don't get me wrong, it's not all about the person in the garage. It could be the small business, but that's where I would like to see it in 5 years. That said, in 5 years, I wouldn't be surprised if we had a lot of the film and video crowd using this product, and we had put a lot of effort into helping out with that. I'm pretty sure that there's going to be a strong computer vision component in anything we do, because visual servoing, visual identification is one of Ross's strong points, and UI design is, I think, one of Tormach's strong points. And so being able to having a product that is easy to use and also easy to teach in a dynamic environment where you're using a camera at the end of the robot to determine where stuff is, I think I anticipate we'll see a lot of that in 5 years. I don't know if that answers your question.
No, that absolutely
Right.
does answer my question. Yeah, thank you. Well, yeah, what I was curious is how is this in 5 years? Is this machine just a stepping stone to larger, more complex industrial robotics, or is this that for the end user, right? Am I teaching my students this machine so that in the future they're running a factory full of ABBs or whatever? Or it seems like what this machine is doing is sort of unique in the market or in this sector, which is really why I'm attracted to it. Or
It
a lot
is-
of us are probably.
It is unique largely because there's no other robot that runs natively on ROS. So there are ROS drivers for some of these other robots that we've talked about, but they're like 60 hertz drivers, and you don't get a lot of feedback from the device itself. So you can do a lot of interesting stuff with ROS with this robot that you couldn't do with ROS with those other robots. But it's all the concepts are the same. I mean, touching off a tool frame using a 4-point method is the same on this robot as it is on a FANUC. So you could teach industrial robot concepts with this robot quite easily. And I don't know what we're going to do in terms of large or small. I can tell you the very first step we've taken is a step in size down from this product. So we've got a 2 kilogram robot that we're calling the ZA2 that we've been working on, and it's less expensive. And what I think will be powerful about that is I mentioned, our user forums where we're trying to get people to share code. We've got a GitHub repository for these shared example codes. I don't know if you're a teacher, you probably know about Arduino, and maybe you're familiar with Arduino sketches. And when I've taught students at the University of Iowa programming or any kind of interface with the real world, you bring up the blink sketch on Arduino and people read it and they say, oh man, that was easy. Look, I can make it blink twice as fast. Or, hey, instead of an LED, I could toggle that output. I understand how to do this now. My hope is that if we can make a smaller one that's cheaper and more available, we'll get more and more people doing stuff like, oh, I wanted to send a text message, so I wrote some code that integrates with Twilio and sends a text message. Here's how I did it, right? And the more community involvement we get in that, the better everybody else will be, because you'll be able to roll all that stuff back into your own application pretty easily. So my hope is, right now it's me, a couple other developers, and a couple of our beta users who are posting, hey, look what I did on the forums. If we have 2,000 of these things out in the wild in a couple of years, and even 10% of the people are active in sharing that code back, you're going to find some examples of some pretty interesting stuff that gives you kind of a leg up, helps people stand on the shoulders of giants.
Oh, terrific. Thank you.
Thank you.
I'm glad you mentioned kind of the small scale manufacturing within garages and everything. I actually, because of COVID and everything, I actually started a business essentially exactly on that premise. I've noticed a lot of companies locally here in Canada, they've been struggling with getting stuff shipped in and struggling with finding things needing to be made. So we formed a business specializing in fully automated 3D printing. So we have a fleet of robots and fleet of printers all working completely autonomously. And our next steps is we want to add in a robot arm and everything to automate packing to the next step. And a lot of people just don't realize how insanely productive setting up automation is. Stuff like being able to, the entire reason my company could succeed is because it was fully automated and I could go deal with other things. I could actually have a social life and all of that. So it's definitely really cool seeing this.
I mean, yeah, we're not, I completely agree with you, Philip.
And then kind of on a lighter note, what do you guys at Tormach think of what Shane did, attaching a chainsaw onto one of the robots?
All right, so I get this message on Slack from Shane, and he goes, I'd like to create my own tool as an STL file and then bring it into the collision model so it doesn't collide with the robot itself. Can I do that? And I said, yeah, that's easy to do. We can do that. Why don't you just send me the STL file and we'll do it for you. And then he sends us the STL file. It's a chainsaw. And I said, what on earth are you doing with this robot, Shane? Why is the tool you're attaching to this robot a chainsaw? He said, no, I'm working on something. I'll let you know when I'm done. And then that video came out, and it's, he's a lot of fun to work with.
That's hilarious. That's great.
And now we have an example up. I was like mentioning those example programs, and one of these things is what is it? Attach a custom tool. So yeah, there you go. New chainsaw. This is Shane's contributed code. So yeah, that was a fun experience.
That video is what got me hooked on these. Is seeing seeing essentially it written in Python allows so much more flexibility compared to PLC programming and all of that.
I assumed he was going to put a camera on it and use it to film some videos. That's what I thought he was going to do with it. So we were pretty surprised when we got that message, and then even more surprised when the video came out. But yeah, so it's a lot of fun. All right. Well, we've gone a little over time. Does anybody have any other questions, comments, feedback? Okay. Well, hey, thank you so much. I really appreciate you taking the time. We'll probably do a couple more of these webinars. I don't know if the next one we do will probably be on a specific topic like probing or machine tending or, I don't know, welding. So if there's anything you particularly want to see, let us know. Otherwise, keep an eye out on your email inboxes. We're going to start doing kind of a weekly update email with either links to some quick tip videos that we've produced, or here's when we expect these things to be for sale, or that type of thing. So we'll keep in touch with you that way, and you can always reply to that email and ask questions.
Thank you so much. This has been exciting and useful.
Great. Thanks, Bo. I appreciate it.
Yeah,
Thanks.
thank you.
Thank you, everyone.
All right. Take care, everyone.